Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is Stat 101, Major 2, Term 231. Let us have a look to the exam and solve it together. The first part, multiple choice questions. First question, a box contains 5 yellow balls, 4 black balls, and 1 green ball. So we have 5 yellow, 4 black, and 1 green. 2 balls are drawn in succession without replacement. So we are choosing 2 balls without replacement. Without replacement means we take the first ball and we don't put it back. So when we choose the second ball, there will be 9 balls to choose from. Now the total of balls 5 plus 4 plus 1 is 10. So in the first choice, I have 10 balls. The question, what is the probability that the first ball is yellow? Now you have 10 balls, 5 of them are yellow. What is the probability that you select a yellow ball? 5 out of 10. So this is the probability that the first ball is yellow. And when we say and, it is multiplication. So the probability that the first ball is yellow times the probability that the second is green. Well, now without replacement, so we have 9 balls because we selected already 1 yellow ball. Now the number of yellow balls is 4 because we selected 1 of them, and there are 4 black and 1 green. What is the probability that we select a green ball from these 9? 1 because we have only 1 green. Multiplying these two, we have 5 over 90. Put it in the calculator, you will change it to a decimal. You will find that the answer is 0.0555. So the correct answer is 0.056. The second question, an experiment is to toss a fair coin 3 times. This is a known experiment. The first coin could be head or tail. And then if the first ball is head, then if the first coin is head, then the first could be also head or tail. And if the first is tail, the second could be head or tail. These are 2 coins, but we have a third one. So again, here we have H and T and H and T everywhere. So in fact, there are 8 possibilities. Usually with coins, if you toss 3 coins, the number of outcomes would be 2 to the power 3, which is 8. And you can write all of these outcomes. So sample space S would consist of, we have H, this is the first possibility. H, T, second possibility, and so on. You will find 4 possibilities. Start with H and 4 outcomes, and 4 outcomes start with T. And the total would be 8 outcomes. So this is the experiment in general. Okay, you should understand this experiment and keep it in your mind. This is the last one. So 2, 4, 6, 8 outcomes. Let A be the event of observing a total of 2 hits. So he defines A to be the event of observing a total of 2 hits. Every time you have 3 coins, so here we have 3 hits. No, he says total of 2. Here we have 2. So actually, you will find that HHT, HTH, and THH are the only outcomes with 2 hits. And B, the event of observing a hit on the first toss. So if you look to these 8 outcomes and write all the possibilities when the first toss is a hit, you will find the first 4 possibilities. So H consists of 4, B consists of 4 outcomes. So he defines 2 events, A and B. What is the question? The last one is HTT. His question, find the probability of A given B. Well, this is a conditional probability. It has a definition. The definition is probability of A intersection B over probability of B. That's the definition of A given B. Probability of the intersection over probability of this one, B, the second one. Well, what is A intersection B? You have A and B in front of you. How many outcomes in the intersection? So intersection means in both events. So HHT is here because here all the events, all the outcomes that start with H, here also, but this one is not here. So we have HHT and HTH in the intersection. So what would be the probability of the intersection? We have 2 only. So it would be 2 out of 8 because the total number of outcomes is 8. So this is the probability of A intersection B. What is the probability of B? How many outcomes in B? 4 over 8. So this is the probability of B. So 8 cancels with 8 and you have 2 over 4, which is half. So the correct answer is C. If you tossed a die 30 times, then you recorded the results of the 30 tosses in the table below. So this is an experiment. We tossed a die 30 times. We got 1 3 times, 2 10 times, 3 5 times, and so on. So if you add the numbers here, 3 plus 10 plus 5, you will find it 30 because the total number is 30. Now the question, what is the probability of 2? Find the experimental probability of 2. What is the probability of 2? Well, 2 appeared 10 times. So probability of 2 would be 10 out of the total number of tossing this die, which is 30. So the answer is 1 over 3. So part D is correct. A new treatment is developed. It's said that the probability of a randomly selected patient being cured by this treatment is 0.75. So 0.75 is a probability. And we can call it P. P is 0.75. If 5 patients receive this treatment, so this is number of patients, we can call it N. So we understand if we have a number and a probability, this experiment follows the binomial distribution. And in the binomial distribution, we have N and B. What is the probability that at least 4 will be cured? At least 4 means X is greater than or equal to 4. At least 4 means 4 or more. At least 4. So how many patients are there? There are 5 patients. So if the number of patients is greater than or equal to 4, it would be either 4 or 5 because the maximum number is 5. So we should use the formula of the binomial distribution to find these 2 probabilities. Well, I can find, you can write probability of 4 is, the formula is NCX. So N here is 5, so it's 5C4. This is probability of 4 times P, which is 0.75, to the power X, which is 4, times Q, which is 1 minus 0.75, This is probability of success because he is asking about cured. Cured here is success. 1 minus 0.75 is 0.25 to the power 5 minus 4, which is 1. There is no need to write 1, or just write it, okay? So this is the probability of 4. Probability of 5 would be 5C5 times 0.75 to the power 5, 0.25 to the power 5 minus 5, which is 0. And you can put this in the calculator and find that the answer is 0.6328. And let me tell you something. Assume that he is asking for probability of greater than 1, or probability of 4 plus 2 plus 3 plus 4 plus 5. And there is a way in the calculator, instead of writing these two like this, you can use the summation. There is a summation in the calculator. If you write summation and you take x from 4 to 5, because here x could be 4 or 5, and you write here in C4, you write it in, which is 5, Cx. So x runs from 4 to 5, and you multiply this, but you need to write in the calculator times 0.75 to the power x, because we always raise p to the power x, times 1 minus 0.75, which is 0.25 to the power 5 minus x. You can put this in the calculator, and you will find that the answer is 0.6328. So either you use this one, or if you can use summation like this, it would be faster than using this one. So the correct answer is B in this case. Question 5. The number of traffic accidents in a small city has a rate or average of 3 accidents per week. When he says 3 accidents per week, you understand that this is a Poisson distribution, and that the average, which is lambda, is 3 per week. And week here is our segment of time. So when he says what is the probability, which is t in the formula represents the number of segments. What's the probability of at least 1? At least 1 means x is greater than or equal to 1. This is at least 1. So greater than or equal to 1. So at least 1 means 1 or 2 or 3, greater than or equal to 1. In 2 weeks, so he is working with 2 segments. So t is 2. Well, the formula is probability of x for the boson would be equal to lambda times t to the power x and e to the power negative lambda t over x factorial. This is the formula of boson distribution. But there is a difference between boson and binomial. In the binomial distribution, n is 5. So x runs from 1 to 5. So x here works from 1 to 5. So when he said at least 4, greater than or equal to 4, I have only 2 possibilities, 4 or 5. But here, there is no limitation for the number of x, I mean upper bound. There is no upper bound. So it starts from 0, but we don't know where does it stop. It continues, the values of x, 0, 1, 2, 3, 4. So how can I find probability of x greater than or equal to 1? I cannot say probability of 1 plus 2 plus 3 up to where there is no limit, upper limit. So the only way here is to write it 1 minus probability, the rest probability, the following, I mean, the probabilities that are not here. We have probability of 0 plus probability of 1 plus and so on. So when he says greater than or equal to 1, so all of these probabilities, but we know that the total probabilities, the sum of all probabilities should be 1. This is known fact. The sum of all probabilities should be always 1. So greater than or equal to 1 would be from P1 to ever, it would be 1 minus P of 0 or probability of 0. So this is the only way here to find probability of x greater than or equal to 1. We write it 1 minus probability of 0. And this would be 1 minus probability of 0. Now x is 0. So lambda times t would be 6. So we have 6 to the power 0 times e to the power negative lambda t, which is 6, over x factorial, which is 0 factorial. And now I can use the calculator to find 1 minus, actually 6 to the power 0 is 1, and 0 to the power 0 factorial is also 1. So you just, if you know these two facts, you can write it 1 minus e to the power negative 6. This will simplify things for you. And put it in the calculator and find the probability of 1 or 1 minus e to the power negative 6. You will find that the answer is 0.9975. So the correct answer is B. The sixth multiple choice question, the number of telephone calls passing through a switchboard has a Poisson distribution. Okay, a second question about Poisson distribution with a mean of 2 per minute. Here the segment is minute and the average per segment is 2. So that's lambda. The expected number, which is also another word for the average, mean or expected number is the same. The expected number of phone calls that pass through the switchboard in 3 minutes. So he's talking about 3 segments. So T is 3. The expected number, which is a mu, is defined to be lambda times T. So actually lambda times T here in the formula refers to mu, the average in 3 segments. The average in one segment is lambda. The average in T segments is mu, and T here is 3. So mu is 2 times 3, which is 6. So the correct answer is C. The monthly income of 2,000 workers at the Microsoft plant is distributed normally. So we have a normal distribution. And this is the number of workers, 2,000 workers. Suppose the mean of the monthly income is, so mean is mu. So we have mu 1250. The standard deviation, which is sigma, is 250. The number of workers who can earn between 750 and 1,500 per month is, so he needs the number of workers. I have 2,000. What is the number of workers that are between 750 and 1,500? Well, I'll start by finding the probability that the income is between $750 and 1,500. And that's the monthly income. The income follows a normal distribution, the income. So the income is X. So what is the probability that the income is between 750 and 1,500? So that's the question. When I answer this question, I'll multiply the probability times 2,000 and find the number of workers. How to find this probability? We have to change it to the standard norm. And we know that Z equals X minus mu over sigma. So this would be probability of 750. This is the value of X. We subtract from mu, which is 1,250, and we divide by sigma, which is 250. Less than, now X, when you subtract minus mu over sigma, is Z. And here also we have 1,500. We subtract from mu and we divide by sigma. Putting this in the calculator, we will find that, well, 750 minus 1200 will give you here -2 and here 1. So now we need to find the probability that Z is between -2 and 1. How can we find this probability? Well, we'll find it from the table. The table that we have, the table of Z, starts from 0 to a number. So he gives always this area. But I need the area from, probability means area. So when he says probability, it means I need to find the probability from -2, this is -2, up to 1, and here 1, for example. Okay. So I need this probability. So how can I find it using the table? It would be probability of, I'll call it, okay, I'll just not write anything. It is probability of 1 plus probability of -2. Because, yeah, okay. If I use the table, I can find this probability up to 1 immediately from the table. How? Look to Z equals 1. See, he gives you the probability from 0 to Z. So if this is 1, then when you look to Z equals 1, which is this number, 0.3413, so 0.3413, this is the probability of 1, probability from 0 to 1. But I need from -2 to 1. So how can I find this probability from -2 to 0 and add it to this one? There is no negative in the table, but if I find the probability from 0 to 2, because symmetric, because of symmetry, it is symmetric. So the probability from -2 to 0 is exactly equal from 0 to 2. So to find the probability from 0 to 2 now, I need to look to the value of Z equals 2. So here Z is 2, 0.4772. So 0.4772 is the probability from 0 to 2. Now, if you add these two numbers by the calculator, you will get 0.3413 plus 0.4772. You will find probability of 8185. So to find the probability from -2 to 1, I find the probability from 0 to 1 plus from 0 to -2. From 0 to 1 is 0.3413. From 0 to -2 is equal to 0 to 2, which is 0.4772. Adding these two probabilities will give you the probability from -2 to 1. Now, this is the probability that X is between 750 and 1,500. But he's not asking about the probability. He's asking about the number of workers who earn between 750. So how to find the number of workers? I multiply 0.8185 times 2,000, okay? Because the number of workers is 2,000. The answer is 1637, so that's the correct answer. For a standardized normal distribution, that's Z, the value of Z0 such that probability of Z is less than Z0 is 0.21. Find Z0. You need to understand how to answer this question. And you need to understand the graph of the normal distribution. This is Z and this is 0. These two areas are symmetric. So this area is 0.5 and this area is 0.5 because the total area is 1. So when he says Z0, Z0 is a value of Z. So it's a value here. It could be 0, it could be -1, it could be 1. Okay? So it's a value here. So the probability that Z is less than Z0 means the area to the left of Z0 is 0.21. So if can Z0, my question, can Z0 be here? What is the area to the left of Z0? All of this area is to the left of Z0. Could it be 0.21? No, because this area alone is 0.5. This is more than half. So it's around 0.7. It can't be 0.21. So if you understand this, you will understand that Z0 cannot be to the right of 0. Z0 has to be here. So to the left of 0. So this area could be 0.21 because the total area here is 0.5. So this could be 0.21. Good. So you understand from here that Z0 is a negative number. So the answer cannot be A or D. Okay. Now how to find Z0? Well, the table doesn't work with this area. The table works only with areas from 0 to this area, to Z, to a positive Z, not to a negative. Okay, so if I use this Z0, if I find the area from 0 to Z0, if I have this area, I can find Z0. Well, can I have this area? Of course, it is 0.5 minus 0.21, because we know that the area to the left of 0 is 0.5. So 0.5 minus 0.21 is 0.29. So what is 0.29? It is this area. And it would be this area too, because symmetric. So this area would be the same like this. If I find this Z0, I can find this Z0 from the table. This is in fact negative Z0. If I find it from the table, I can find the original Z0. So what to do? Put this area, look to this area inside the table. This is 0.29. So we go to the table. We search for 0.29. If you look here, if you start from here, 0, this column, go by this column quickly, 0.03, 0.2225, 2831. Okay, 28, continue to the right, you have 2910. So this is 2910, this is 2881. This is closer to 0.29. This is the area I am searching for, 0.29. And Z would be 0.81. 0.8 and 0.1. This will give another unit here. So 0.81. So Z0 is 0.81. But this is not the Z0 required by the question. It is this number. This number is 0.81 because this area is 0.29. So how to find Z0? It is negative 0.81. So B is the correct answer. It has to be negative. The graduate record examination scores are normal. Okay, another question with the normal distribution. Mean 500, this is mu. Standard deviation 75, this is sigma. He needs the 90th percentile. What do you know about the 90th percentile? Again, we are talking about the normal distribution. And this is X, because I'll call it X. The normal distribution is usually, the standard normal is called Z, but any other normal, we call it X. Here there is a mu. It is not 0, 0 for the Z. Here mu. He needs the 90th percentile of X GRE score. 90th percentile means it's the value of X. Value of X again. Okay, so it's a number here. If mu is 500, it would be 500, 550, 600, 400, something like this. But it should be the 90th percentile. What is the meaning of 90th percentile? 90th percentile means it is better than 90% of the scores. So could it be here? Well, this number is not better than 90%. It's better than 30%. But here, this is the 90th percentile. If this is the 90th percentile, P90, then this area should be 0.9. The area to the left of 90th percentile is 90%. Well, we know that this is 0.5. So 0.9 minus 0.5, this is 0.4. So to find the 90th percentile, I need to search for 0.4 inside the table. But the table is table of Z, not of X. So if you look inside the table, and search for, if you give him 0.4, search for 0.4, you will get the 90th percentile of Z, not for X. No problem. Let us get it and see how to answer the question. So I want to search for 0.4 now. We'll do the same. Start from the first column here. Go immediately until you see 0.4. So I have 0.38, 0.4032. 0.38 is less than 0.4. Go to the right. Continue up to reach until 0.4. Well, I have in here 3997. This is very close to 0.4. And this is 0.15. This is higher than 0.4 by 15, but this is less than 3. 3 out of 10,000. So this is the area I need. So 1.2, that's the value of Z. And here we have 8. So Z is 1.28, Z0. So the 90th percentile is 1.28. So if the question was, what is the 90th percentile of the standardized normal distribution? The answer would be 1.28. This is the answer. But he's talking about a normal distribution, not the standardized. So we know that Z is 1.28. What is the relation between Z and X? Z is X minus mu over sigma. So if you multiply, Z times sigma would be X minus mu. And if you solve it for X, then X is take mu to the other side, Z times sigma plus mu. So I need to find X. I have sigma, Z, and mu. Sigma is 75. The value of Z, the 90th percentile, is 1.28. Mu is 500. If you put this in the calculator, you will find that the answer is 596. And by the way, by looking to the 4 choices, you understand that it can't be 481404 because they are to the left of 500. They can't be the 90th percentile. The 90th percentile, 90%, better than 90% of the data. 519 is very close to 500. 596 is the best choice. So it's clear that really 596 is the 90th percentile. Okay, the other type of questions, problem-solving questions. The shelf life of a particular cheese is normally distributed. Okay, another question about normal distribution. Mean of 12, so this is mu. Standard deviation of 3, this is sigma. About what percent of cheese lasts between 10 and 15 days? So the life is X. The shelf life is X. This life between 10 and 15 days, he is asking about probability that X is between 10 and 15. I need to change X to Z. So Z is X minus mu over sigma. So X is 10 here, the value of X is 10. 10 minus mu, which is 12, over sigma, which is 3, less than X minus mu over sigma is Z. 15 minus 12 over 3. This is the probability of This is -2/3. If you put it in the calculator and take 2 decimals, because the table works with 2 decimals. So 666, I write it 67, less than z, less than 1. So I need to find this probability between -0.67 and 1. This is similar to what we mentioned before. I need to find the probability that z is from -0.67 to 1. I need this probability. The table gives me this probability immediately from 0 to 1. So this would be, I look to 1. I said, I think we found 1 before. Yeah, at 1. It is at 1, it is 0.3413, 0.3413. This is the probability from 0 to 1. I need the probability from 0 to -0.67. I can't find it by the table, but I can find the probability from 0 to 0.67 positive, this one. They are the same. So I look to 0.67 in the table. And 0.67, I have zero point 0.6 here. For the second digit, I have to go to 7, which is this one. So 0.67, this one. This is the probability that Z is between 0 and 0.67, 2486. 2486. You add them and you find the answer. So 0.3413 plus 0.2486. The answer is 0.5899. So this is the probability. Well, the question is, what is the percentage? At what percent? And at what percent you multiply the probability by 100. So 58.99% or just 59%. So 59% of cheese lasts between 10 and 5 days. From a random selection of 60 cheese. So if you select 60 cheese, how many would you expect to last over 7 days? So what is the probability that out of 60, how many out of 60, how many will last over 7 days? So let us find the probability that the life of the cheese is greater than 7 days. Okay, this is here lasts between 10 and 15, here lasts over 7. So probability of X greater than 7. I change it to Z, 7 minus mu, which is 12 over 3. It would be probability of Z greater than -5 over 3. And this is -1.666. So I choose -167. So now I need to find this probability from the table because I have the table of Z. So where is -1.67? This is 0. This is Z. -1 is somewhere here, -1.67. I need the area to the right of this number. I need all of this area. How can I find this area from the table? Well, I know that this area to the right of 0 is 0.5. So all what I need to find is this area. I cannot find this area from the table. I have to find the area to the right from the table. So instead of finding the area from 0 to -1.67, I find the area from 0 to +1.67. So if you want to write Z is between 0 and 1 point, this area, this probability, you can find it from the table. So let us go to the table to the number 1.67. So this is 1.6 and 7 is here. This is 7. So the probability is 0.4525. 0.4525. 0.25. So the probability of Z greater than negative 1.67 would be 0.5 plus 0.4525. So it would be 0.9525. So this is the probability that the cheese will last over 7 days. If you have 60 cheese, you can multiply 0.9525 times 60 cheese, and the answer is 57.15. So 0.9525 times 60 is 57.15. So the answer would be 57. I expect 57 will last over 7 days. So that's good. 95% will last over 7 days. That's good. So we know that it will last at least 7 days or more. The random variable x has the following distribution. This is a discrete distribution. The values of x, 1, 2, 4, 10, these are the 4 values. And this is the probability of each value. If you add these probabilities, you should get 1, because the sum of all probabilities is 1. Find the probability of x exceeding 2. Exceeding 2 means greater than 2. So probability that x is greater than 2. Well, if you look to the values of x, this is 1, this is 2. They are not greater than 2. 4 and 10 are greater than 2. So in fact, he is asking probability of 4 plus probability of 10. Well, probability of 4 is 0.2 and the probability of 10 is 0.3. So the probability that x exceeds 2 is 0.5. Find the standard deviation of x. Well, the standard deviation for the discrete distribution is square root of summation x minus mu square times probability of x. This is the formula, and you can find the answer here by the calculator. Okay, if you go to stat mode and mode stat 3, mode stat, and press 1, and you have the values of x. We need the frequency, because the frequency here we will put in the frequency 0.3, 0.2, 0.2, 0.3. The probabilities, we will put it in the frequency part. If you don't have the frequency, you should go to shift mode, down, stat, and then make the frequency on. So you put the values of x, 1, 2, 4, 10, and you put the frequency 0.3, 0.2, 0.2, 0.3, and then you press on, and you go to shift stat, and when you go to shift stat, you will have number 4 variance. So you press number 4 and you choose sigma x, because here these are all the possible values of x. So this is a population, in fact. So sigma x, the standard deviation, will give you the standard deviation. See here, sigma, we deal with sigma. And you will find the answer exactly. The other way is to find this one. So I have x, I need to find the mu first. So the definition of mu, it is summation x dx. So I multiply 1 times 0.3 plus 2 times 0.2 plus 4 times 0.2. So multiply x by its probability plus 10 times 0.3, and you add all of them. So mu is 4.5. And now sigma would be square root of. You subtract each x from this mu. So 1 minus 4.5. 1 minus 4.5 squared. Well, this is 3.5 squared. It is negative 3.5, but when you square it, the negative will disappear. So I'm not going to write negative. It is in fact 3.5 squared times what? times the probability of 1, which is 0.3, plus, do the same, 2 minus 4.5, it's 2.5. Of course, it's negative, but when you square, the negative is not important. Plus 4 minus 4.5, this is 0.5 squared, times 0.2, plus 10 minus 4.5 is 5.5 squared, times the probability of 10. And you put all of these in the calculator and you find the number. The answer would be 3.748, and this would be the same number if you use the calculator as I told you. Question 3. There are 27 students in a section of Stat 101. So this is N number. And the probability that a student attend any lecture is 0.9. So this is a probability. Whenever you find the number and the probability, the question is talking about binomial distribution. Find the average number of students attending a class. So he's asking about mu. Mu of the binomial is n times p. That's the definition of mu. So n is 27 times 0.9, and you will find that the answer is 24.3. So the average number of students attending a class is 24. The probability that more than 25 students, so he's asking the probability that x is greater than 25, more than, so there is no equality, are attending the lecture. So what is n? 27. I told you x for binomial starts from 0 up to 27. The last number is 27. Did we say here from 0 or from 1 before? From 1 to 5. You can find 0. Well, probability of 0 would be 0, 5, 0. This is to the power 0. No, there would be a probability, okay? From 0 to 5. And here from 0 to what? To 27. So greater than 25 means probability of 26 plus probability of 27. And you can write them 27, that's n, C 26 times p, which is 0.9 to the power 26. 1 minus 0.9 is 0.1. 27 minus 26 is 1. Plus, this is the probability of 26. Probability of 27 would be 27 C 27 P, which is 0.9 to the power 27, 0.1 to the power 27 minus 27, which is 0. So you can put this in the calculator, or you can use summation x from 27 to 20 to 26 to 27 and 27 cx times p, which is 0.9 to the power x and 0.1 to the power 27 minus x. Either use this one or this one, and you will find that the answer is 0.233. So that's the answer. That's the probability that more than 25 students attending the lecture. The last question, I have a table, total number, statistics of infected individuals, total number of individuals in the experiment, 2,223. Suppose an infected individual is chosen. What is the probability that he is a man? Probability of men. Well, the total number of men, 1692, over the total number of people in the experiment. So this is the probability of M, and you can approximately equals to 0.07. Probability of S or B. There are two ways to find the probability of S or B. You can use the formula probability of S plus probability of B minus probability of the intersection. This is the formula. You can use that. So probability of S is 7, total number of S survived, 6706 over total number of individuals, plus probability of B, I have total boys 64. Since the denominator is the same, you can add all of these numbers over the one denominator you have. And S intersection B, this is survived and this is B. So 29 boys survived. So this is the intersection. The number of individuals in the intersection is 29. And if you add 706 plus 64 minus 29, you will find that the answer is 741. So, and this is actually 1/3. You can find also the probability directly from the table by looking to, you need the probability of S union B, the union. So this is all of S, these numbers, all S, and all B will be here. So you don't count 29. You just add 706 plus 35, because 29 you are already taken them with S. So you don't take it again. So you add 706 plus 35, it would be 741. So you can write immediately 741 over 2223 if you understand this this thing. How can you find it directly like this? Conditional probability of W given D, by definition, it is probability of W intersection D over probability of D. So go to W and D. This is W and this is D. Well, 104 is in the intersection. 104 is in the intersection of W and D. So probability of W intersection D is 104 divided by 2223 if you want. And probability of D, total number of D is 1517. So 1517 divided by 2223. You don't have to write this one because they cancel with each other. And the answer would be 104 over 1517. This is the probability. This was the last question. I hope you benefited from solving, looking to the solution of this exam, but you need to solve it and practice a lot. Best wishes in the major.